I'm going to explain how to approach exercise 3. In this exercise, you were asked to draw two rectangular boxes with a given ratio. In this case, the first box has a ratio of 1 unit in height, 2 units for width, and 2 units for depth. The second volume has a ratio of 1 unit in width, in depth, 1 unit in width, and then 2 units as in height. We'll draw the two rectangular boxes with the drawing approach called paraline drawing technique. Then use your imagination to merge these two volumes and then create different aggregate shapes. Then we'll draw those aggregate shapes again in paraline drawing technique. Let's draw the first volume. I marked the dimension on the drawing. For the first volume, we'll draw 1 inch by 1 inch square at the top surface. So the first volume has a height of a ½ inch. Therefore, it satisfies the ratio 1 to 2 to 2. The second volume will have a height as 1 inch, and the top square would be a ½ inch by a ½ inch square, like the dimension labeled here. To draw the first volume, we can simply just draw a rotated square at the top surface. The rotated square is a 1 inch by 1 inch square. And then the height would be a ½ inch. We draw vertical lines down and measure a ½ inch. Then we draw lines at the bottom edge parallel to the top edge. Then we get the representation of the first volume. Similar, we can draw the second volume as a top surface as a rotated square, measure a ½ inch by ½ inch. Then draw a vertical line down, measure 1 inch. All the height vertical line should measure 1 inch, and then draw lines parallel, the bottom lines parallel to the top edge, and similar to the right side, the bottom edge would parallel to the top edge. That's how we draw the two geometric volumes. And next, we want to imagine how to merge these two geometric volumes into an aggregate shape. Here I'm going to use a pen. We'll do some sketch lines, use the green color. So if we want to draw the top aggregate shape, the second volume sits at the rear corner of the first volume. And we know if we equally divide the top surface, then we get a ½ inch by ½ inch. That would be and if the second volume, you imagine, move on top, the second volume would sit right in at the rear corner. So therefore, we can simply just draw the base square of the second volume. Then we draw vertical lines, measure 1 inch, represent the height of the volume. So it's 1 inch, it will be somewhere here. Then we use our parallel lines. We know the top surface is a square, we'll complete the square. Then we get the representation of the second volume stacked right on top